I welcome all the TY BTech Mechanical Engineering students for this program elective second presentation. Myself, Professor Dr. S.R. Kumbar. I am presenting the course Smart Materials and Structures. Course code is ME328, which is having the 3 credits and 3 hours per week. The course teacher mobile number and email ID is given in front of you. So in this presentation, I will go through first I will introduce the subject, then course outcomes, then topics covered, then I will discuss teaching methodology, career opportunities, and finally why to choose this course. So specifically for the smart materials and structures, this course is having the different 5 course outcomes. So first course outcome is at the end of the students. At the end of this course, the students will be able to describe the behavior and applicability of various smart materials. Course outcome number two, demonstrate the design methods of smart sensors and actuators. Then CO3, model smart sensors and actuators for specific applications. CO4, demonstrate the techniques of fabrication of smart systems. And finally, the CO5, design simple smart system for specific applications. So if we see, the smart material is any material which is changing their properties by some external stimuli. So that stimuli may be pressure, heat, pH, chemical, light or voltage. So these stimuli responsive polymers, we are calling this as a smart materials. They may contain safe memory polymers, self-healing polymers, delivery agents. In these smart systems, we are going to utilize the sensors and actuators along with the soft robotics. So there are different types of the smart materials that starting from thermoelectric, chromogenic, electrostatic, magnetostatic, then piezoelectric, safe memory alloys. These are the some of the important smart materials that we are going to study under this course. So if we see the smart materials and structures, as a structures, we are going to utilize the so many different types of the components, likewise actuators, sensors, and to make the system happen, we are going to have the closed loop system through the different actuators like tandem or nerves or the different sensors like as a whatever the different sensors human being is having. So we are continuously engaging, and that is transferring the data from one system to another system in the environment. So under this smart system materials and systems, we are going to have the 6 units. First unit will cover the overview of smart systems. Second, smart solids and fluids. Third, design principles of sensors and actuators. Fourth, modeling of smart sensors and actuators. Fifth, fabrication methods for smart systems. And sixth, applications of smart materials and systems. So these are the three different 6 units that we are going to cover under this course. Now, how we are going to cover this? So, teaching methodology, there will be the interactive and engaging learning. You will find we will use the blending learning approach, where in combination of lectures, online resources, and hands-on activities will be used to reinforce the concepts. Then we will use the active learning, which will encourage the students to engage with real-world case studies and current industry trends. Then we will have the problem based learning. Students will work on the solving real life problems involving the application of smart materials and structures. So along with this, we will use the technology enhanced teaching, wherein we will use the simulation tools, that is use of software for modeling and simulating the behavior of smart materials in various environments. Along with that, we will also try to use the virtual labs, wherein you will get the hands-on experience using virtual tools for testing and designing smart material systems. Apart from that, regularly we will have the lectures and discussions for clear understanding of smart materials, their properties and their applications. We will have the lectures which covers the conceptual foundation. Then apart from that, we will discuss the industrial case studies, that is real world examples will be discussed, which will bridge the gap between theory and practical. So as far as practical learning is considered, we will have the collaborative tasks on designing and fabrication course, fabricating structures or devices using smart materials. That will be group activities, and definitely there will be another one, that is discussions on modal discussion forum on various real life problems. Then teaching methodology covers also the assessment and evaluation. The assessment of the course will cover the ISE 1, 2, 3, UT1, UT2 and ESE. ISC 1 will have the group activity or work, which will be of 10 marks. ISC 2 will be MCQ, which will of 8 marks. Then discussion forum will have the 2 marks. Then as usual, UT1 25 marks, UT2 25 marks, and ESC 100 marks. So total weightage is given in front of you. So here, assess assignments and quizzes, regular assignments to enforce key concept will be given. In semester group activities will encourage creativity and practical applications. And finally, there will be the presentations. Their group, the students will present in their group the group activity. So why you should go through this? What are the career opportunities? So this is one of the emerging career roles. So these are the emerging career roles that you can go for. That you can work as a smart materials engineer, you can work as a structural health monitoring specialist, material specialist, robotics and automation engineer, nano materials specialist likewise. Apart from that, there are the various industries wherein you can go for utilizing this knowledge: aerospace and aviation, especially automotive, civil engineering, healthcare. All these are the different industries, consumer electronics, wherein you can use the knowledge of smart materials for various applications. So this is the rising demand. There is a rising demand for sustainability infrastructure, and definitely these advancements in wearable technology. So why to choose this course? Because this is the relevance in emerging technology. This is a cutting edge field. You will get the expertise in next generation materials used in diverse applications. This is the interdisciplinary. You will have the exploration, fusion of material science, engineering, robotics, and automation likewise. Future proof skills you will get. You will be equipped with the skills in developing adaptive, self-healing, and energy efficient systems. And industry demands, because growing industry applications where it they demand essentials for industries looking for smarter, after sustainable solutions in infrastructure, vehicle, and electronics. High demand for professionals in R&D, design, manufacturing, testing of smart materials. So why you are going to choose this? Because you are going to learn the collaborative learning. Then you will get the opportunity to innovate materials which will improve the energy efficiency, reduce cost, reduce waste, and enhance material longevity. Then save future technologies, work and materials that respond to environment changes like self-healing and self-memory materials. So as far as CAGR, that is compounded annual growth rate is considered, the smart material market is expected to register 13.04% CAGR. 46.34% of the global market share is announced by North America in 2022. And this particularly Brainy Insights research focus gives the market research of the smart materials. Again, this is the emerging research. They are giving that 14% based upon applications, the sensor segment is expected to register CAGR of 14.0%. So I welcome all the students to the future of this engineering, that is the smart materials science structures. Explore the world, join this particularly course and explore the world of smart materials and structures. So thank you.